Welcome back for our third day of 5C or 5-3. So, looking at this one, we're going to move on to yet another factoring strategy. The method we're going to talk about today is when we're factoring the sums and differences of cubes. So, we're going to be factoring in the form of these two things. Okay? So, when we're talking about factoring these sums and differences of cubes, we're going to break it down into a linear piece and a quadratic piece, okay? And again, that's going to help us because once it's split up, now you know how to solve each of those individual pieces. So that's what this formula is for, okay? It's to break down the sum and differences of cubes into a linear and quadratic piece, so then you can solve each of those pieces individually. Now, in order to make this work, you need to remember the structure of how exactly you were breaking it down, okay? So, my first hint for you is always write each piece as a cube first, okay? When you're factoring, I always write each piece as a cube. Now, what do I mean by that? Well, what I mean by that is I'm going to rewrite this as x cubed and 3 cubed, okay? So it's going to help you to recognize each of those pieces, okay? And now, how we're going to do this is the linear piece. The linear piece is literally just what you have written up there, x and 3. And in the linear piece, the sign is always going to match what you already have, okay? So you literally just get x plus 3, okay? Those two pieces that make up those cubes. When you make your quadratic, okay, now your quadratic is going to be made up of 3 pieces. Each of those pieces is going to be pulling from what you already have. So the first piece of the quadratic is pulling 2 pieces from the x. So x and x, which is x squared. It's going to be, the next piece is also pulling 2, but it's pulling 1 from each. It's going to pull an x and a 3. And then the final piece, again, is pulling 2 pieces together, but it's pulling 2 pieces from the second. So 3 and 3, 3 times 3 gives me 9. That last piece is always going to be positive, and the middle piece is always opposite of the linear one. Okay, opposite of what you already have in the linear piece. Now, probably the biggest struggle of this is simply remembering that pattern. Okay, so I have a bunch of this front side dedicated to just recognizing that pattern. Okay, so first step, always write it as a cube first. So x cubed and 5 cubed. The linear piece is literally just those pieces. So x minus 5, because this time there's a minus there, okay? That sign always carries to the linear piece. The quadratic is pulling 2 things at a time. So the first one is pulling an x and an x for x squared. The middle is pulling 1 of each, so x and 5 is a 5x. And the last piece is pulling 2 from the second piece. So 5 and 5 gives me 25. The last one is always positive. The middle is always the opposite of the linear piece. All right, and so again, I'm sorry that there's so much repetition on this front page, but that's the best way to get really good at this. So this next one, 8x cubed, well, that is taking 2x and cubing it, and then 27, is 3 cubed. So again, you're always wanting to break them down into the cubes. So the linear piece, still just taking both of those pieces and writing them together. So the 2x and the 3, and it's a minus because you see a minus right there. The quadratic is pulling two pieces together at a time to make up each of its pieces. That front piece is 2x and 2x. So 2x times 2x is a 4x squared. The center is pulling one from each, so a 2x and a 3. 2x times 3 is 6x. Then the last piece is pulling 2 from the second. 3 and 3. 3 times 3 gives me 9. The last one is always going to be positive. The middle is always the opposite of the linear piece. All right, looking at the next one. So I'm going to break this up. This is 5x cubed and 4 cubed. So looking at those, now I'm ready to break it up. That linear piece is literally just writing those pieces together. So 5x plus 4. And again, we know it's plus because that's what's showing in the problem. And now for the quadratic. The quadratic, again, is pulling two pieces at a time. So the first one is 5x and 5x. Well, 5x times 5x is going to be a 25x squared. The middle is pulling one of each, so 5x and 4 is a 20x. The last piece is pulling 2 from the second, so 4 and 4 is 16. The last piece is always positive. The middle is always the opposite of whatever the linear piece was. And finally, this one, we have 3x cubed and 4y cubed. So again, always write them as the cube that formed them. And then we're going to break it down. So the linear piece is just those written together, 3x and 4y. Again, I know it's positive because that for the original problem was positive. Now to make the quadratic. Well, the quadratic is always made from taking two pieces at a time. So 3x and 3x, 3x times 3x is 9x squared. The middle is always one of each, so 3x times 4y is a 12xy. And the last piece is 2 from the second, so 4y times 4y is 16y squared. The last one is always positive. The middle is always opposite of the linear piece. All right, so first and foremost, we need to make sure that we're comfortable with how to break up each of these cubics into its linear piece and quadratic piece. Okay, so that's going to be our first goal, just making sure we can do this. Now, just like the previous 2 days that we've done, once we're good at the factoring, now we have to actually finish solving. Okay, so for solving, it's going to be the same thing that we've been doing. Okay, we're going to have to factor and then wrap it up by solving. So here, that x cubed, again, first step when factoring is you always want to show them as their cubes. So that is x cubed, and that is 3 cubed. Okay? So the factoring piece, well, this is like what we did on the front side, right? The page that we just finished. So the linear piece is always just whatever those two pieces are. And I know I'm adding because the original problem was adding. Now to make the quadratic. Well, the quadratic starts with 2 from the first piece, so x times x gives me x squared. Then one of each, x times 3 gives me 3x. And then finally, both coming from the second piece. 3 times 3 gives me 9. The last one is always positive. Middle is always opposite of the linear piece. So first and foremost, we need to make sure that we know how to factor these, okay? And again, that's a practice that we did on the front side. Now when we look at this, we need to finish solving this, okay? And solving it actually isn't that bad. You should now, like the back of your own hand, recognize what solution that will give. For x plus 3 to be 0, that means x is going to have to be negative 3. What about this piece? That quadratic. What would make that quadratic 0? Well, we need to think about this. That actually doesn't factor, okay? There's nothing you can do to multiply to 9, add to negative 3. You can't solve by square rooting. So for the quadratic, you're actually always going to need the quadratic formula, okay? Always. And a little hint for you that you'll catch on to, you're also always going to get imaginary solutions from that quadratic. It's just the inherent nature of how this plays out, okay? So you're always going to need the quadratic formula to finish these sums and differences of cubes, and it's always going to give you imaginary solutions for the quadratic formula. So let's run through the quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. All right, so we have that. And now let's keep it going. So remember, I always want to simplify this first. So I see a 9 minus 36 in there. So 9 minus 36 is a negative 27, which should make sense to you because if I'm telling you that you are always going to get imaginary solutions, it should make sense to you that the inside of the radical is negative because square rooting a negative is how you get those imaginary solutions. So just a little check for you so you understand to make sure how you're getting these answers. That square root of negative 27. I'm going to do a little scratch work over here because the fact is negative means I need the I. And 27 can actually break down using a perfect square. Okay, 9 and 3 make up 27. And again, the reason I would do this is because the square root of 9 is 3. So this is going to become 3 plus or minus 3i square root of 3 all over 2. And that is how you get your 3 solutions. And again, as long as you're good at your chapter 4 content, then having to use a quadratic formula isn't going to be that huge of a deal for you. Okay, so let's look at our next one. So here we have 2x cubed and 1 cubed, right? So if we're being told to solve this thing, well, first we need to factor it. So we're already partway there. Now I just have to write those two pieces together. And again, I know it's a minus because I started with a minus in the original problem. And now I need the quadratic piece. So 2x and 2x gives me a 4x squared. 2x times 1 gives me a 2x. 1 times 1 gives me a 1. That last term is always positive. The middle is always opposite of whatever the linear piece has. So we have this factored out. So now we need to actually solve it. Again, the linear piece should never really be that bad, okay? This time it's a little bit trickier because to show when 2x minus 1 is equal to 0, well, even that is going to take a little scratch work, okay? So that first solution is actually x equals a half for the linear piece, okay? And now for the quadratic piece. Well, I hope that you remember what I said we need to do in order to solve that quadratic. You're always going to need the quadratic formula, and you're always going to get imaginary solutions from it. So to use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c, oh, there we go, all over 2 times a. So remember, the first thing I always want you to simplify is inside the radical. So here I see 4 minus 16, so that's going to be a negative 12 inside the radical. Hopefully the square root of negative 12 resonates with you. I like that it's negative because I know that's going to give me the imaginary solution I'm looking for. And I see that it simplifies. Okay, 4 is a perfect square that pulls out of 12. So I break it down like that, and so that is going to give me 2i square roots of 3. So looking at this, I can take one last step in simplifying it. So I see negative 2, 2, and 8 are all divisible by 2. So I actually get negative 1 plus or minus I square roots of 3 over 4. I can reduce that all the way down to this. Again, another chapter 4 skill that we worked on. And that's how I get my 3 solutions. This 1/2 up here, and then these 2 down here. So I do want to take a moment, now that we've discussed all of that, I do just want to make sure that we review and know when it's appropriate to use the other method still, okay? Because that's going to be the ultimate goal, is knowing when can I use each of these methods, okay? So let's take a look at this. Here, I see something where I can pull an X out. So remember, when there is a GCF that pulls out, you absolutely need to do so. So I'm going to pull the X out. And now notice I'm left with a quadratic that actually factors. And so that is how I get these 3 solutions. Remember, now X would have to be 0 for that, would have to be negative 4 for that, and would have to be negative 6 for that one. So remember, that was from our 5.3a notes. Okay, remember that method. Remember in 5.3b, we talked about what to do when there were 4 terms. Okay, remember when we had something that had 4 terms in it, we factored by grouping. So from that first one, I pulled out an x squared. From the second one, I can pull out a 2. And remember, we liked when we got 2 with the same parenthesis because that's what makes this whole method work. It lets me pull the x plus 7. I can pull it out front, factor it, And then my second parenthesis is made up of the leftovers, the x squared and the 2 that were left behind in that factoring process. Then, of course, to finish it off, what would make each of these 0? Well, that one's easy. A -7 would make that equal to 0. That one takes a little bit more work. And remember, never be afraid to show me your work when it's harder, when it's not a basic linear, okay? This time I can use square rooting, right? I can simply move that 2 over, I can subtract it over, and then I can square root it. So I'm going to end up with plus or minus because I'm square rooting, and because I'm square rooting a negative, the square root of 2 doesn't simplify at all. So again, just a brief recap so you can remember where we've been so far, okay? Because we still have a ways to go with the rest of our factoring adventure. So why don't you please scroll down, write that summary for me, okay? Make sure you do that. And a good thing in your summary would be comparing and contrasting these different methods. This is our third method that we've talked about. And remember, ultimate goal here is you need to be able to tell them apart and know when to use each one. All right, so make sure you do that for me. Thank you for joining me. I come back ready to do your practice work.